Level 1. Camera Obscura. A dark box with a tiny hole that projects an image by letting light from the outside pass through it, forming a blurry inverted image. The idea dates back to ancient China and is the founding principle of photography. Level 10. Daguerreo type cameras. A light-sensitive silver-coated metal plate is placed inside a sealed camera and is exposed to light through a glass lens, forming an invisible image on the surface. It is then exposed to mercury vapor, which reveals the brighter areas before chemicals remove everything that didn't react. This method was developed in 1839 by Louis Daguerre and produces extremely detailed images. One of the earliest surviving examples is the Boulevard du Temple, showing one of the first ever people captured in a photograph. Level 20. Kodak box cameras. A handheld camera that replaces metal plates with roll film, allowing multiple photos to be taken on one strip. Each exposure creates a hidden chemical image that is later developed in darkrooms. It was developed in the late 1880s by George Eastman and would make photography accessible to the public. Level 25. Color film photography. Color film uses multiple light-sensitive layers stacked on top of each other, with different layers reacting to red, green, and blue light separately. During development, dyes form inside these layers to recreate a full-color image. Level 30. 35mm film camera. A standardized 35mm film format that made cameras smaller, faster, and easier to mass produce. It's basically just the Kodak box but better in every way. Level 40. Polaroid cameras. A camera that develops photos instantly using self-processing film. After capture, chemicals spread through the film layers to develop the image within minutes. Developed in 1948 by Edwin Land, it let people see the image straight away. Level 50. SLR cameras. Single lens reflex cameras use a mirror and prism system so the photographer sees directly through the lens. When the shutter is pressed, the mirror flips up and the light hits the film instead. Cameras like the Nikon F were actually used in the 1960s during the Olympics. Level 60. DSLR cameras. Digital single lens reflex cameras use CCD or CMOS sensors made of millions of tiny silicon pixels. Each pixel converts incoming light into electrical signals, turning brightness and colors into ones and zeros. A Bayer filter splits light into red, green, and blue, and the camera combines this information to rebuild a full color image. The first image sensor was developed in 1969 at Bell Labs, but only started being used in cameras in the late 1990s by companies like Canon and Nikon. Level 70. Mirrorless cameras. Mirrorless cameras will remove the mirror system, allowing light to hit the sensor at all times. Instead of an optical viewfinder, they use a live digital preview from the sensor, making them smaller and faster. Developed in the late 2000s by companies like Sony and Panasonic, they improved autofocus, burst speed, and video performance way beyond traditional DSLRs. Level 75. Smartphone cameras. Smartphone cameras use extremely compact CMOS sensors. Since smaller sensors capture less light, phones rely heavily on software processing and AI corrections to improve detail. Phones like the Galaxy S25s sometimes use AI enhancement on the moon to increase resolution. Here's a little example that I took. Okay, so we got the moon right there. We're gonna zoom in. I'd say probably 50 times is enough. Look at that. Level 80. Computational cameras. Cameras begin combining multiple images to get more detail than a single capture ever could. The biggest camera as of 2026 is the Vera C. Rubin Observatory camera. Its camera is 3200 megapixels. For comparison, the newest iPhones are only about 48 megapixels. One image from this camera is over 6 gigabytes. Space telescope cameras similar to Rubin capture massive space images, like this huge stitched image of the Andromeda Galaxy, where thousands of photos are combined into one giant image, revealing a lot of detail. Level 90. Software imaging. Image quality becomes less about the camera and more about the software processing, where images are enhanced, merged, and corrected to improve clarity. It's used in astronomy. Techniques like deep sky stacking and planetary imaging combine thousands of frames to create one ultra-detailed image of objects like Jupiter or the Orion Nebula. Level 95. AI image enhancement. AI systems analyze images and rebuild missing detail or increase resolution. It works by analyzing millions of real images and then using that data to predict new pixels. This method was developed in the 2020s by companies like Adobe, Google, and Nvidia. Level 100. Reality reconstruction. A theoretical camera system that measures depth, light direction, and different wavelengths of light to fully reconstruct reality. Using infrared, spectral imaging, and light field capture, it creates an interactive digital world that can be explored like real life.